Hi, this lesson is about the derivatives of inverse trigonometric functions. So remember, what is an inverse trigonometric function? We use those in order to solve angles. So if y equals sine of x, then its inverse, we would say x equals sine inverse of y when we rewrite this in terms of its corresponding inverse trigonometric function. If y equals cosine of x, then you would say x equals cosine inverse of y. So the x's are the angle, the same way the x's are the angle in the trig function. And tangent of x, that means that x would equal tan inverse of y, again, where x is your angle. Now, there's also inverse trigonometric functions for cosecants, secant, and cotangent. We're not going to discuss those in this lesson. So here's a little reminder of when we would use inverse trigonometric functions. So if you wanted to solve the cosine of theta equals a half, then theta equals cosine inverse of a half. Again, rewriting it in this form. And then you have to remember, well, when is cosine equal to a half? And that's something that we should know from memory, from pre-calculus, not really something you need a calculator for. We know we're going to express our angles in radians based on this statement here. So cosine is equal to a half when your angle is 60 degrees, and 60 degrees is equivalent to pi over 3. But since cosine is positive in more than one quadrant, it's also positive in quadrant 4. With a reference angle of pi over 3 in quadrant 4, you would say that theta is 5 pi over 3. In other words, it would be 2 pi minus pi over 3 gives me my angle in quadrant 4. So we have two answers, theta equal to pi over 3 and theta equal to 5 pi over 3. That's where cosine of theta equals a half. Okay, for the next one, we want to know when is sine of theta equal to negative root 2 over 2. So again, that's something that we should know by memory. Root 2 over 2 is a 45-degree angle, which is right here, but it's negative. So when I find theta for sine inverse of negative root 2 over 2, I need to be in two quadrants where your sine function is negative, and that's in quadrants 3 and 4. So if my reference angle is 45 degrees, which is equivalent to pi over 4, to get into quadrant 3, it's pi plus pi over 4, which gives me 5 pi over 4. And to be in quadrant 4, similar to the last example, it's 2 pi minus the reference angle of pi over 4, and that gives us an answer of 7 pi over 4. So two places in radians, two angles where your sine of theta is equal to negative root 2 over 2. That's 5 pi over 4 and 7 pi over 4. Okay, so let's talk about derivatives. So we're going to learn three derivatives for inverse trig functions. So if I wanted to know the derivative of sine inverse of x, the derivative is 1 over the square root of 1 minus x squared. And that's that same x that's there gets squared. For cosine, the cosine inverse, the derivative is negative 1 over square root of 1 minus x squared. So it looks really similar to this one, except cosine inverse has a negative. And for tan inverse, the derivative is 1 over 1 plus x squared. Or because addition is commutative, sometimes it's written like this, you get the same result. So remember other notation for sine inverse. You might see this in other books or other videos. It could be called arc sine of x, and they mean the same thing. Same thing for cosine inverse, that's arc cosine of your angle. And for tan inverse, it could be called arc tan of some angle that I'm calling x. So that's just a little bit of notation here for you to remember. Okay, so let's calculate a derivative. So I want to calculate the derivative of y equal to sine inverse of 3x. Now, this is now a composite function where the sine inverse is the outer and 3x is the inner, which means I need to use chain rule. So first I apply the derivative of the outside function, which is sine inverse, which means I have to use that definition. But my x is now 3x. So that's going to be 1 over the square root of 1 minus 3x to the second power times the derivative of the inside, which is 3. So that gives me 3 over the square root of 1 minus 9x squared. Okay, now we do the next one, which also requires us to use chain rule. This is 3 times the cosine inverse of 2x. So I'm going to be using this formula above. And then that derivative is going to get multiplied by 3. So the derivative of the outside function is negative 1 over the square root of 1 minus 2x to the second power, times the derivative of the inside, which is 2. But my coefficients, the 3, the negative 1, and the 2, gives me a coefficient of negative 6 on the next line. And when you square the 2x, you get negative 6 over the square root of 1 minus 4x squared. Okay, so here's another one where I'm going to be taking the derivative of tan inverse of t squared raised to the 5th power. This is also chain rule. I have the outermost function is to the 5th power, the middle one is tan inverse, and the inside function is t squared. So we have 3 layers. So remember, we always start with the outside one first. So this is the derivative of, when you raise that to the 5th power, we apply power rule. So it's 5 times tan inverse of t squared raised to the 4th power times the derivative of the inside, which for us will be the middle. The derivative of tan inverse means I have to use the formula above, which remember is this. So that's going to be 1 over 1 plus t squared, and then times the derivative of the innermost function, which is the derivative of t squared is 2t. And when we put that all together, the 2t and the 5 multiply to give you 10t in the numerator, along with tan inverse of t squared to the 4th. And when you square the t squared here, you get 1 plus t to the 4th in the denominator. Okay, so here's another one. We want to find the derivative of w squared sine inverse of w. Here we have to use product rule and just product rule. It's w squared, the first function, times sine inverse of w, the second function. So when I set up my product rule, I let f equal w squared, f prime is 2w, g is sine inverse of w, and g prime is the formula I just gave you at the beginning of the lesson, which is 1 over the square root of 1 minus w squared. Then we just have to put it together. So I did f g prime plus g f prime, so that's this line right here. And when we put it together, all I did was I multiply these two. You end up with the derivative of w squared over the square root of 1 minus w squared plus 2w sine inverse of w. Okay, here's another one where we're going to evaluate the derivative. We want to evaluate f prime at 2 for f of x equal to tan inverse of x squared. Here again, we're going to use chain rule, where the outside function is tan inverse and the inside function is x squared. We always start from the outside and work our ways toward the inside. So the derivative of tan inverse of x squared is, the tan inverse part is 1 over 1 plus x squared to the second power, times the derivative of the inside, which is 2x. So when I square the x squared and multiply these two, you end up with 2x over 1 plus x to the 4th. And now I'm ready to substitute in 2 in for x, and I get 2 times 2 over 1 plus 2 to the fourth. That gives me an answer of f prime of 2 is equal to 4 over 17. Okay, that's it for this lesson. Give the homework a try. Good luck.